Hi, we'll start today our first lecture of the course Mammalian Toxicology. Uh, so what is mammalian toxicology? The topics include the basic concept of poisons and their commonalities with hormones, their interaction with hormones, the toxicant exposure as well, routes, uptake, and sites, the toxicant mechanisms of action, storage, and clearance, as well as the toxicant metabolism and activation. So the toxicant roles as a topic, we'll talk about how it's development, endocrine and reproductive function effect, and how it is involved in carcinogenesis, our diet and lifestyle, and concurrent exposures. So basically, the lecture topics is divided into general principles of a toxicology, absorption, distribution, and excretion of toxins, risk assessment, biotransformation of toxins, non-organ directed toxicity, target organ toxicity, toxic agents, applications of toxicology. There is a famous quote which says that all substances are poisons. There is none which is not a poison. The right dose differentiate between poison from a remedy. Okay, that's mean if you take a drug for a certain disease, if you increase the amount of this drug, it will soon be a poison. So how is assessment occur in our course? You will have 20% of the assessment grade on the midterm, 20% on the presentations, 20% on papers presentations, and 40% on the final exam. We will explain later what these include. So actually it's a 60% on activities and 40% on the final exam. This is the main reference we will use either in my lectures or the presentation you will do. It's called the basic science of poisons. So for the assignments, you have three different assignments. Presentation one assignments, you use the reference from the book, the same book, absorption, distribution, and excretion of toxins, page, and these are the pages. The second assignment is a presentation assignment as well about food toxicology. And the third assignment, actually, it's a papers of toxicology, and I will explain that more by the end of the lecture. So you need to write the aim, results, figures only, and summary and conclusion. For the template of your presentation, you need to stick for this template to have a uniform template for all of you. Okay, so you'll have the first slide having the university logo, title of the talk, course name and code, and submit it to myself, student name and ID, and you'll stick to the same format of font as said in the other slides. So what is the general principles of toxicology? We'll talk in these two slides about the history and the scope of toxicology. It has been defined, toxicology has been defined as the study of adverse effect of the xenobiotics. Xenobiotics is any substance that enters the body and it doesn't relate to the body, so it's called xenobiotics. Historically, toxicology formed the basis of therapeutics and experimental medicine. Toxicologists are concerned with the mechanisms of action and exposure to chemical as a cause of acute and chronic illness. They are involved in the recognition, the toxicologists, of course, involved in the recognition, identification, and quantification of hazards resulting from the exposure to chemicals and the public health aspect of chemicals. Toxicologists have been intimately involved in the discovery and the development of new drugs, food additives, and pesticides. The clinical toxicologists develop antidotes, treatment regimes to lessen the poisoning effect from xenobiotic injury. The science of the poison or toxicology dates back to the earliest human who used the animal venom and the plant extract for hunting, warfare, and assassination. You can see that even the papyrus of the Egyptian contain information to many poisons, including hemlock, the state of poison of the Greeks, aconite, a Chinese arrow poison, opium used as both poison and antidote, and the metals such as lead, copper, and antimony. A Greek physician, which is named Dioscoridis, in the court of the Roman Emperor Nero, made the first attempt to describe, draw, and classify poisons. His classification is convenient and remained standard for 16 centuries. Cleopatra, of course, Cleopatra's knowledge of nature and primitive toxicology permitted her to use the more genteel method of falling on her sleeve. During the 4th century, poisonings in Rome reached epidemic proportion. Even the women conspired to remove men from the population whose death they might profit. This means women in the Rome used to poison their husband if they get a lot of money after their death. So they tend to kill them. Nero used poisons to do away with his step brother and employed his slaves as a food taster to differentiate between edible mushrooms from their more poisonous kin. So Nero used these slaves to check the food if it's poison or not poisonous. So you can see here, of course, you don't need to memorize the dates, okay? And the years. The development of the early advances in analytical method, we'll talk here about the development of the science of the poison or the toxicology. It starts dated from 1836 through the development of method for arsenic analysis, followed by combined method. This is the analytical methods to detect. Combined method for separation analysis of arsenic and the mercury. Soon after that, the development of screening method for general poisons, followed by detection and identification of phosphorus. This is the development of the early measures toward the analytic methods. Soon, in the same while, there is early mechanistic studies, like a study of the arrow poisons, the mechanism of action, a study of the carbon monoxide combination with hemoglobin, study of mechanism of action and site of action as well. The active anti-helminth from fern poisonous mushrooms. Then starting from the 20th century, 1923, start of introduction of new toxicants and antidotes, like the mechanism of action of arsenic and other metals on the SH groups. And SH groups, actually, it's groups that is attached to our amino acids. Drugs in India start to emerge. Introduction of modern antidote for cyanide toxicity. Development of the bridge antidote for arsenic. So it was developed 1945. In the meantime, introduction and study of DDT used in agriculture, and as well followed by introduction and study of generally all organophosphorus compound used as a fertilizer in the agriculture. So what is a different area of toxicology? You have majorly 3 different areas: mechanistic toxicology, descriptive toxicology, and regulatory toxicology. For the mechanistic toxicology, it deals with identifying and understanding the cellular and the biochemical and the molecular mechanism by which these chemicals exert its toxic effect on living organisms. While for regulatory, it is the responsibility for deciding on the basis of data provided by descriptive. So the regulatory toxicology need data coming from the descriptive and the mechanistic toxicologists, whether a chemical poses a sufficiently low risk for its use. The descriptive toxicology concerned directly with the toxicity testing, which provide information of how safe this compound. They provide information about the safety evaluation and the regulatory requirements. Of course, all these three areas intersect in the risk assessments. What's risk assessment is used to demonstrate an adverse outcome, like for instance, cancers, if this compound or this toxicant can lead to a cancer or other disease. And this can be seen in laboratory animals as an experiment before introducing any toxicant or any drug to a human to see if it's directly relevant to human or not. So you need, if you discovered or made a new compound that you think that it is a drug, still it is a toxicant, and you need to do a lot of risk assessment tests on animals to make sure that it will not have adverse effect on humans. So there are other specialized areas of toxicology, such as forensic, clinical, and environmental toxicology. For the forensic toxicology, it's actually a hybrid of analytical chemistry and fundamental toxicological principles, and concerned primarily with the medical legal aspect of the harmful effect of chemical on human and animals. While for the clinical toxicology, it is an area of professional emphasis in the realm of medical science that is concerned with disease caused by or associated with toxic substance. So clinical toxicologists are physicians actually who receive special training in the emergency medicine and poison management. For the environmental toxicology, it focuses on the impacts of chemical pollutants in the environment on biological organisms. So what is the classification of toxic agents? Toxic agent can be classified according to target organ, use, source, effects. So you can see according to target organ, either the toxicant agent will affect kidney, liver, blah, 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 etc., etc., etc. Or according to the use, if it's a pesticide, it's a food additive, it's a solvent, or according to the source, is this toxin coming from animal or plant? Or its effect, is it cause cancer, mutation, liver injury, kidney injury, etc.? It can classify it as well according to physical state. If it's this toxin is a gas or dust or liquid, according to chemical stability or reactivity. So if it's a flammable, oxidizer, explosive, as you can see from the symbols down in the slide, it can be classified as well according to the chemical structure. If it's aromatic, halogenated hydrocarbon, it can be classified as well according to the poisoning potential. If it's a very toxic, extremely toxic, slightly toxic, and as well according to the biochemical mechanism of action. That's mean of how it works inside our body. So, and usually this category is the most informative category about the characteristics of the toxin. So let's have some definition about toxicology. So what is a toxin? Toxin is a toxic substance that are produced by biological systems such as plant, animal, fungi, or bacteria. So they are naturally produced, the toxin, while a toxicant, it's a toxic substance that are produced by or a byproduct of anthropogenic activities. It's not directly produced by animals or plants. It's a byproduct or produced by activities, usually human-made activities. Examples of that, veralanin is produced by a mold. This one is called toxin because it's naturally produced by a mold. While dioxin is produced during the production or combustion of certain chlorinated organic compound. So it's a byproduct, not naturally occurring. So in this case, it is called toxicant. So you need to understand clearly what is the difference between toxin and the toxicant. Some toxicants can be produced by both natural and anthropogenic activities or human-made activities. The famous example is polyaromatic hydrocarbons. The polyaromatic hydrocarbons produced by the combustion of organic matter, which may occur both natural process, like what's happening in forest fires, and through human-made activities like combustion of coal for energy production and cigarette smoking. You can see arsenic, for example, it's a toxic metalloid, may occur as a natural contaminant of groundwater or may contaminate groundwater secondary to industrial activities. So it can occur naturally, in this case, it's called toxin, and it can be a toxicant as well because it is a byproduct of industrial activities. Such toxic substances are toxicant rather than toxin, because although they are naturally produced, they are not produced by biological system. Okay.
دكتور بس عندي سؤال إنه يعني التوكسينز أحيانا ممكن يكون التوكسيكنتس ممكن يكونوا natural مش ضروري يكون human made يعني.
Yes. Sometimes.
فإنه بضل اسمهم toxicant حتى لو natural يعني.
Yes, we can say toxin because they can be produced as a byproduct or due to human-made effect. Okay. So these conclude our first lecture, and now we will have a discussion for the lecture.